done. This presentation for the Free Energy Special Interest Group made on the 2nd of August 2017. Please understand very clearly that this presentation must not be thought of as an encouragement that you should attempt to construct anything shown here or discussed here, as this presentation is for information purposes only. Please understand that we live surrounded by an energy field of effectively unlimited power.
Sorry, pause for this. I want
Power is something that we can access for our own use in 20 different ways. However, if the method of accessing this power is a passive one, then please understand that you yourself can and will affect the flow of power. That effect is called the U factor. Now, if you want a copy of the information that I'm going to talk about, you can download it from www.freehyphen-energy-FESIG That will download this particular document if you want to reference it. Okay, this presentation is primarily very simple and intended for people who will see this on the web who are not members of FESIG at all. Okay, now an interesting thing that appeals to most people is a permanent magnet. Even children are very keen to play with permanent magnets. Permanent magnet is a very interesting device in that it is a room temperature superconductor of magnetic energy. So if you consider two magnets together, as shown here, the one on the left is fixed. The one on the right you can consider as being able to move vertically and only vertically. It's like it's attached to the outer edge of a disk. So in the position where it's shown there, the north of the moving magnet is attracted to the south of the fixed magnet, and the south of the moving magnet is attracted to the north of the fixed magnet. That gives you a force indicated by the red arrow, and the moving magnet is pushed downwards. Now, what happens if you leave it be is that the moving magnet goes past the fixed magnet, and the forces that have been pushing it forward reverse. And if you leave it be, the magnet will end up as close as it can get to the fixed magnet in its closest position, which everybody knows, but it's no use to most people. But what we can do is we can move the fixed magnet away before its presence becomes a problem. So if we slide the fixed magnet to the left, and the sliding apparatus has another fixed magnet to the right, replicating the position that was there before, the downwards push on the moving magnet is continued. And if you keep doing that, you can manage to get the moving magnet going continuously. Now, there are quite a large number of designs which use that principle. One of them that's well known is by Stephen Kundell, and he creates rotation of the shaft, marked number 10 in this diagram, by wobbling left and right the moving arm, which is shown here vertically. That moves the magnet 51 either towards the magnets marked 33 or to the right towards the magnets on the right. And that causes rotation of the central power shaft. It looks more complicated when you see a lot of them done. But the thing is, every vertical strip here is a stator magnet, and it has got two rotor magnets on each side, one on each side, so there are two of them. And there are three moving so-called stator magnets, and therefore you have got four rotational magnets. This is shown in considerable detail in the ebook, which you can download anytime you want. Now, that idea of moving a magnet that is a stator magnet so that it doesn't get in the way is very common. This one here is from Don Kelly of the US. He demonstrated this maybe 20 years back. He uses two motors connected to a whole series of rocker arms. And the rocker arms have got magnets attached to their ends. And when the motors are run slowly, the large disc in the middle starts to rotate. And it actually rotates quite powerfully because the force that's exerted on it is between the fixed pivot of the rocker arms and the magnets attached to the rim of the wheel. Now, there are lots of different ways to do that sort of thing. And the idea is to put in a small amount of electrical energy to get out a large amount of mechanical rotary energy. All of the rocker arms are mechanically linked together. Now, the thing you should understand about magnets is the repulsion of similar poles is slightly stronger than the attraction of dissimilar poles. In other words, if you push two north poles together, they push away from each other more powerfully than if you have a north pole and a south pole moving towards each other. It's not a great difference, but there is a difference. Now, the thing is, if you're using attraction, the magnets are left untouched, and they will last certainly for at least 11 years. Presumably, you can revitalize them anyway by sticking a coil around them and passing a strong current briefly through the coil. But if you are using the repulsion mode, people will find that in certain conditions, you will lose the magnetic power of the magnets in about 3 months. So you need to be careful what you're doing. Now, waving magnets around the place is viable, but it's not necessarily the best way of doing it. There is a very clever user called Charles Flynn, and he demonstrates a way of getting this powerful rotation without having any moving magnets. Now, the way he does that is he takes a disc magnet where the one pole is shown in yellow and one pole is shown in blue. That's going across here. And he has a rotor attached to the output shaft, which is above it. Now, the rotor above it has got just two magnets in it. And the magnetism is manipulated by 7 coils placed on top of the disc magnet. Now, the disc magnet itself is sitting with a hole through it, which allows the rotation of the central shaft. And that central shaft is both output and timing. The shaft itself supports a disc, and the disc has got 2 slots in it. And the slots allow light to pass from light-emitting diodes through the slot to either phototransistors or light-dependent resistors. And that gives you the synchronization. Now, what you do is the magnet on the rotor wouldn't move at all if there's no power to the coils, because there'd be an equal pull to the right and to the left, so it would just stay stationary. But if you power, say, the magnet on the coil on the left, it becomes a magnet, and you make the coil and the current which is marked in blue there. That switches off the attraction, and the rotor moves off then strongly to the right. And the interesting thing, of course, is that only one coil needs to be powered per magnet in the rotor. You can double the output power by using a second magnet on top, and then the two coils that are above and below give a moment. Can be as many rotors as you want on a common shaft, and every time you add a rotor, you increase the power of the motor very considerably. Charles got 20,000 revs per minute from his prototype, and he was using a 9-volt dry cell battery for the input power to those coils. There's only one coil on at any given moment. Now, you can build the unit very compactly, and you have, in this particular illustration, 4 drive sets of powered rotors, and you only have to power up 2 coils on each side of each rotor at any given moment. So instead of having to do all of the coils together, you only do a few. That's a very effective and very powerful method. Now, if you take a look at permanent magnets, you'll discover that in schools, they tell you the wrong thing. The reality is that with the permanent magnet, the magnetic fields rotate around the corners of the magnet. As a result of that, if you angle the magnets, say at 45 degrees, they line up and give you what is effectively a net magnetic force across the row of magnets. Now, Steve Braden of New Zealand has found that the magnetic fields interact eventually if you keep doing that. And he's found that 5 magnets in a row is the maximum before you need to leave a gap before any other magnets are added. There are 2 boys on a YouTube video in the web. They didn't know this, but in spite of that, they got very good results with a row of magnets angled at 45 degrees. Now, the thing is, with a linear magnetic track like that, you can't bend it round into a circle without destroying the magnetic effect. That, of course, doesn't stop us using the strong magnetic push of a short length of straight track. So there's nothing to stop you putting 4 magnets attached to a rotor and putting 4 sets of 5 magnets on each side of those rotor magnets. That will give you strong rotation. And you can, if you want, put pickup coils actually underneath that particular rotor. And the magnets on the rotor will pass just above those coils, and they generate an output. Another person who has used this style of operation is Robert Adams of New Zealand. And he built a permanent magnet motor, which many people think is a pulse motor, but it isn't. It's a magnet motor. It's a very subtle design indeed, very, very subtle. Cunning design. When properly built and adjusted, it's about 800% efficient. That is, you get 8 times more power out of it than you actually put into it. And we are talking electrical power here. The highest powered version of this that I've ever heard built and described outputted at 32 kilowatts of energy, which powered both a business and a household for the person who built it. Now, the thing is, it has got 4 rotor magnets. They're long magnets. The south poles are kept in the center of the rotor. The north poles are on the extreme outside of the rotor. The drive coils and the pickup coils have got solid iron cores. Now, everybody will tell you, oh, you're going to lose power through eddy currents going sideways in those cores. Well, the answer is yes, you do, but you gain more than that because the output from the coils is bigger than the eddy currents by a long way, due to the stronger pull of the rotor magnets. Okay, so what happens is, when you start off, a rotor magnet gets drawn across to a drive, one of the two drive coils, the core of one of those two coils, or to one of the four output coil cores. The thing is, if we did nothing about it, the rotor would stop then and get pulled back to the nearest point to the actual iron core. To stop that, the iron core is surrounded by a coil, and the coil is powered up just enough to stop the backward drag of the passing magnet getting pulled back towards the core. Now that's fine as it goes, but then the rotor continues on round. And the cunning part on this is the power to the drive coil is then cut off. And when it's cut off, you get a back EMF pulse in the coil, and that reverses the magnetism of the coil, and that pushes the rotor on its way instead of hindering it. The same is done for the pickup coils. The magnet comes up, and as it's approaching the coil, you get an output of electricity through the coil around the core. And what happens is, when it reaches the coil itself, the switching disconnects the core coil, and that reverses the magnetism of the output coil, which pushes the rotor on its way. So you're getting a very large push on the rotor, both from the pull of the magnets going to the cores and from the back EMF pushes of the rotor on its way as the magnet has just passed by. Now that's only part of the situation, because Robert has then taken the output of the back EMF and he rectifies that, and he passes that back from the drive windings to the drive battery. And he does the same for the output coils, and he rectifies the back EMF pulse and pushes that back to the output. So he actually regains 95% of the drive current used in this coil, in this design of rotor, and it is very, very efficient. You will notice that in this particular diagram, he's put that this is one of Robert's diagrams. He puts the angles through which you can adjust the position of the various coils. The four output coils and the drive coils are mounted on a disc which can be rotated. This does require tuning, but you can get a very effective method of generating power doing that. All right, moving on then. A simple device that anybody can build is being produced by James Hardy. You'll find a video on YouTube from him. He uses a high-power water pump, and he generates excess energy from the inertia that's generated by this operation. He directs the jet of water onto plates which are attached to a bicycle wheel, which is his rotor. The jet of water hits the actual little plate and pushes the wheel around. The wheel gets pushed around and rotates a generator. And the generator lights a light bulb, and it also powers the water pump. He's actually patented this, but the way that it works is the pump is initially powered by the mains power from an inverter, powered by a battery through a press to make button switch. It goes through a switch powers the pump. The pump takes water from the sump, pushes it powerfully onto a rotating wheel, and then there's a drive to generator. And when the system gets going, you flip the switch here marked B, and the system powers itself. Now that's very straightforward, and it works well. A system like that, which is much more powerful, is a simplified version of a difficult engine to make, a difficult device to make, which is a tapered conical device. This one here, though, has a COP of 4. It's produced by Donny Watts, but it's one that's easy to build. It's self-powered, and you can typically get 7.5 kilowatts of power from a tiny rotor of just 250 millimeters, which is 10 inches. But this is an exponential power engine. So if you double the revs per minute, you get 4 times the output power. Also, the output power is proportional to the square of the rotor diameter. So if you double the rotational speed and double the rotator cylinder diameter, the output power goes up by a factor of 16 times. Now, this machine has got positive feedback. And like the conical Clem engine, you have to put throttle to stop it rotating so fast that it drives itself apart and disintegrates itself. But the general principle is very simple. You have in the center a cylinder which is cylindrical. On the outside edge of the cylinder, there are little jets which are effectively jet engine jets which push the rotor round. The rotor is fed by water from a sump. It goes through your control valve, which allows you to stop it running itself to pieces. It goes through this pump and gets pumped into the cylinder. And once it gets going, you don't need the pump anymore, so the pump can be switched out. And the rotating cylinder spins so hard and so fast that it actually keeps itself moving all the time. And the output shaft here is geared up to a generator and spins a generator, which gives you a lot of output power. It's an interesting sort of concept, and it works very well indeed. It involves mainly you welding, typically, some metal in producing this thing, but it is effectively an X-shaped support for a circular cylinder disc. What happens is the water is taken from the sump, pushed round, or pulled round rather, by the suction inside the disc, and the disc gets the water pushed out through the nozzles at the edge. The hard thing of this particular design is to get a rotational water fitting, even though the generator itself runs cold at all times. This particular coupling that I'm showing here is rated at 2000 RPM, but you would expect to be rotating your particular cylinder at probably about 400. But this is one of more than one. This is one of several that are available on the web, which you can order and buy in if you want. Now, there is an important factor for boosting the power in this, and that is you've got 16 nozzle jets with a 1.5 millimeter diameter hole in them, inclined at 25 or 30 degrees from the tangent at the edge of the cylinder where it's connected. But what you do is you put a fixed plate onto the housing itself. And it moves past. The jet of water coming out of your jet hits the fixed plate. Now this is important. It's not immediately obvious why this is important, But this is an effect that I'm told is experienced by firefighters holding a hose. If they hold the hose so that the water sprays out into an open area, it's easy. If they spray it onto a concrete wall, they get pushed backwards very strongly. And that's an effect that applies to this particular rotor. But that particular design by Donnie Watts will allow you to generate easily enough energy to power a household. There's no question about that. You're talking many kilowatts of power if you want. And it's very simple. There's no electronics. There's no clever switching. The only thing you got to do is to control the inlet valve once the thing gets going, so that you keep the speed down to something manageable. Okay, next we come to a very effective invention by two French gentlemen, Michael Mayer and Yves Mace. The active material in this generator is iron. Now, iron is just a version of steel which has got a reduced amount of chromium and other additives in it. But this is just an iron bar set into an iron frame, and it has on it. You put DC into, and that turns the entire thing into an electromagnet. Coil number 2 is the hard one. You have to feed coil number 2 with a sine wave at a high frequency. We're talking 21 megahertz. 21 megahertz is not that easy to generate, but if you can generate 21 megahertz, then from coil 3 you can take off large amounts of energy. Where does the energy come from? It comes from converting the iron inside the iron bar from one isotope to another isotope. The iron starts off with isotope 56 of iron and ends up with isotope 54 of iron. And that is a very effective and high-power generator if you can generate 21 megahertz. How are we doing for time?
We're doing fine.
Okay. Tell me when to stop. Okay. Next we have a very simple device indeed. This is a magnetic frame, the sort of thing you can get by taking a mains transformer apart. And into that frame you put a simple magnet, just one magnet, north and south, into the frame. And you pulse a coil on one side with DC, and the coil on the other side gets pulse DC coming out. Technically speaking, yes, what's coming out is really very close to being a sine wave rather than square wave. But forgive me for showing it as square wave, because it's easier for people to understand that way. But this is interesting. What you need to be careful of avoiding is making the magnet too strong. If the magnet's too strong, then the frame gets saturated and your pulsing DC has nowhere to go. You can't over-saturate a saturated frame. So the limitation on something like this is low power. You have to have a frame big enough to carry the magnetic flux that's flowing through the frame itself. This is a well-proven design. It's been proven by people on a forum, and one of the people testing this got an immediate coefficient of performance of 1.5. That is, there was 50% more power coming out than was being pushed into the actual frame. But the problem is, if your magnet's too strong, you will get nothing out. But that sort of design can be very effective. Thane Hines has produced an asymmetrical transformer, and the COP, or coefficient of performance, is always greater than 1. This is a picture of one of the styles of his transformer design. he has put a thick outer ring of conducting magnetic frame around the outside, and he has got two output coils. Coil number 3 is one output, coil number 2 is another output, and coil number 1 in the middle is an input coil. And he's got two output loads, load number 1 and load number 2. Now the thing is, when you pulse this, the power coming along from coil 1 has to go through this narrow section here shown by the blue arrows. And when it gets to the large outer frame, it goes through the output coils and back round to coil number 1. Now that's a relatively ineffective way of doing it. So what you do instead is you notice that when the coils are pulsed, they work fine on the first half of your sine wave, and your problem occurs on the second half of the sine wave because you get feedback from the output coils to the input coils. But in his design, what he has done is he's made the output go through two different paths backwards. One path, the beneficial one with the easier flow, easier magnetic flow, goes around the outside, and it goes in both directions, and it tends to cancel out where they hit each other. And what goes back along the central coil is relatively little of what would normally be there. Now, this picture here shows an actual test frame built by Thane Hines. It's one of several that he built. This particular frame has got a very effective operation. The coefficient of performance of this particular frame was bench tested at 39.6. In other words, the output power was more than 39 times the input power. And that's only because the transformer was asymmetrical. And so it doesn't automatically oppose itself when output power is increased. The way that motors and transformers are built nowadays is symmetrical, and deliberately so. It's a bit like trying to push start a car with 5 people, and you get 3 people at the back pushing the car forwards, and 2 people at the front pushing the car backwards. Not very logical, not very sensible, but this is the way they do it. And because it's symmetrical, it opposes itself internally. And if you want to increase the output power, it's like adding 2 more people at the back of the car to push it forwards, and 1 more person at the front pushing it backwards. So if you increase the power, if you increase the output power, you have to increase the input power, which is ridiculous. You don't need to do that. But you need to understand that we're talking here about transformers and frames. And the snag with these things is that for the frame to be able to carry a large power level without getting saturated by the magnetic flux that you're using, you have to have a very large and very heavy iron frame. You'll notice that in the mains distribution systems, the sub-transformers are in their own separate building. Okay, leaving that and coming on. Asymmetrical is the important point in nearly all of these things. Clement Figura was a very intelligent engineer, and he designed a number of things, but the most important one I would assess is this particular design here. And what he has done is he has created 21 separate electromagnets. The ones in green are input, and there are 2 sets of 7. 7 on the right and 7 on the left. They're both connected to an input at the top, and they have a separate output at the bottom. And what he does is he always has current flowing in one direction through these electromagnets, the green ones. But he alters the intensity of the current flow from right to left to right to left. And that creates an alternating magnetic flow in these yellow electromagnets, which are output magnets. Now, he used a battery in his house to actually generate this particular power, and he created 500 volts from his battery, and he powered his house from it. Now, please understand, if you're trying to replicate this, pay attention to the fact that there are 7. This isn't just being drawn in for fun. There are 7 separate electromagnets on each side, and they are positioned close together, side by side, and they interact with each other as you alter the magnetic flow. The same applies to the yellow ones, which are output. Now, he created various ways of doing this, but you can either use switching to get a difference on that, or you can do what he did, which is use a rotating ordinary small motor, you're moving a switching arm around so that different levels of resistance are switched into the 2 sides. But this is a very powerful and very effective device. And it's something that is potentially able to power households or businesses. People who have got into trouble with the establishment are Barbosa and Lille of Brazil. They produced a generator, which they demonstrated, and they showed it drawing 172 kilowatts out of the ground in a closed loop. Their circuit's not at all easy to follow, quite possibly deliberately so. But they borrowed a meter from the local power company so that they could demonstrate how big the current flow was. And of course, the powers that be promptly said, "Oh, you stole this meter from the local power company. You're thieves." They weren't actually thieves. They borrowed it and they had everything in order. But they have been quiet for a long time. I imagine that they have been intimidated into silence. But the system has been replicated. And as the power is flowing from the earth into your load, the way that you manage to earth your system is very important. This is an exceptionally effective method here. These dots here represent 8-foot-long copper rods being driven into the ground. They're 3 feet apart, and there are a lot of them. The one central strip here is one side, and all the rest are connected together on the other side. And it takes a piece of ground 15 feet by 24 feet to put all those particular rods in. Now, the circuit that's been used on this is shown here. The red line shows you the line, the positive line, the live line coming into this. And the blue line shows you the neutral. It's actually shown in black in America. In this country, it's brown. Oh, sorry, I beg your pardon. It's green-yellow. No, it's not. I tell a lie. It's blue. It is blue in the UK. But in America, it's, that particular one is white. Okay. Now, this earth connection here is shown with these little triangular designations here. The wire is very thick. It's number 6 American wire gauge, which is a thick wire. Now, an interesting thing, you'll notice that this is a continuous loop. It's connected all the way through, round and round, and it is coupled gently and indirectly to the earth. And the power actually flows from the earth through the coupling into this loop, is transformed into a higher voltage, and it comes out as high power output. This particular arrangement here gives you 3 kilowatts of mains power. This unit here on the right is a 3 kilowatt inverter, which initially is powered by a battery, but then after is powered from the ground through the coils. Here, down here, is the continuous loop between the two coils. The coils have been wound on toroids. They don't have to be, but they are in this case. It could be squared rather than toroidal. That is a powerful unit that could be capable of running most households. 3 kilowatts is substantial. Your biggest load typically in a house is a washing machine, which at times can take 2.2 kilowatts. Usually it takes a good deal less. Alternatively, a tumble dryer can take about 2 kilowatts, typically, and they're effective. So you can run a washing machine and or a tumble dryer, which is one of the biggest loads you get in a house. Most of the other things are very small by comparison. Okay, moving on. We have a design of a very tiny little capsule here. This is less than 2 inches long. That is less than 50 millimeters long. This particular device is capable of outputting a kilowatt of power, and they reckon it can last for 70 years of continuous use. Now, it's a very simple design. It's got a quartz tube. I don't think it has to be quartz, but quartz is a good thing. And inside, it has little sections filled with copper powder, or zinc powder, or a chemical mixture. And the chemical mixture is a mixture of cadmium, phosphorus, and cobalt. That is atomic weights 112, 31, and 59, respectively. So all you have to do is make up one of these things. Now, the remarkable thing about this is that it becomes radioactive for about an hour if it's surrounded by an electromagnet and then subjected to a high-frequency electromagnetic wave for a few seconds. The unit is lead shielded for the periods when it's operational, and it is very small. This marked in red here is that little quartz tube of chemicals. The output wires coming off the end caps. This big yellow thing here is a coil, which is part of the transmission coil. So that's the front view, that's the side view, and there's a capacitor built of lead sheets built into the base. Now, the thing is, the circuit is very simple. You merely generate through here an input high-frequency electromagnetic wave, and that activates the material inside in the tube, and that gives you, from a very tiny tube, 1 kilowatt for about an hour. So all you do is, coming up to the hour, is you give it another few seconds of electronic wave, and that keeps it going. Of course, I'm talking about one tube here. I can't think of any reason why you shouldn't have a row of them. So I can't see any reason why you shouldn't have 10 kilowatts or 100 kilowatts if you want. But most people seem scared to try this. I think they're frightened by the idea of having an X-ray, or what would you call it, an X-ray device operating. They're worried about radioactivity, which is not really all that dangerous, and it's easily handled. This is a tiny thing. It doesn't take a lot of lead to surround it. It's quite easy to do. Okay, moving on. Something now that doesn't require any electronics or understanding anything like this. You have a design from Chas Campbell in Australia. This is a very effective system. What he does is he gets an ordinary mains motor. His mains motor rotates at 1,430 revs per minute. And he gears it up through belts and various belts and through a shaft that has a 10 kilowatt flywheel attached to the shaft, and then through another pulley which spins a generator. Now the thing is, once this gets up to speed, what he does is he switches the input to the motor over from the mains to the output of the generator. Now this is very convenient, and it powers itself and it powers other equipment that he wants to use, like drills and saws and the like. This is a photograph of his actual first construction. While he only has one flywheel here, which is the dark red object here, he does have these yellow discs attached to his pulleys, and they are slightly operational as flywheels themselves. The way that the flywheel gathers energy is it has a continuous inward acceleration. As Newton has pointed out, if you have something in motion, like a piece of the outside of a flywheel, it will keep going straight. But if you have something like a wheel here that pulls it round in a circle, to get it moving round in a circle, that piece of rim has to move inwards. So it has to accelerate inwards, and it does it all the time. So it's continuously accelerating inwards. Now that acceleration inwards creates an excess of power from the surrounding energy field, and that power becomes available in the flywheel as excess power. Chas has built or has proposed a larger version which can be home built using straight pieces which you can weld together quite easily. And all the details of welding it together and how to construct it and so on are in the main ebook, which you can download. Not these notes, but the main ebook. Right. This rotor is also weighted at the outside edge with concrete, which I haven't shown. But the cunning bit is it has a drive strip here. And the drive strip sticks out beyond the rim of the wheel. Now, this wheel is mounted horizontally, and surprisingly, it's just free to rotate. It doesn't have any form of drive other than this drive strip. Now, the drive strip is actually driven by 3 separate small drive motors with flywheels on. The flywheels have got a drive friction wheel which connects with that drive wheel, the friction strip, drive strip, and that pushes the large rotor around. Now, the thing is, there are 3 of these, and there's only one drive strip. So these give the big flywheel 1 push per revolution. But there are 3 of them, so the flywheel gets 3 pushes per revolution, and the little flywheels only have to supply 1. So they rotate at their no load setting, which is 2.2 amps on mains, and the generator in the center can generate pretty much anything you want it to. So that's a very effective system which has got no electronics. It has no special constructional skills needed. It's a little large, admittedly. You need about 10 foot square and about 4 feet high in your back garden, if you have a back garden, in order to make this thing work. But you get a lot of power out of that. You can drive any generator you like from that particular arrangement. Okay, moving on again. Just let me stop and check. How are we doing for time?
Carry on, because it's
Okay, okay. Tell me. All right, moving on now to the recent year of 1939. William Skinner of America produced a gravity-powered design, which he kept refining. And you'll find his fifth generation unit, which was filmed by the BBC Pathé News people in 1939, which is the beginning of World War II. And this system is so powerful that it was driven by a loop of thread. Now that system that he is operating has enough power for him to drive his metal cutting 12-foot long lathe and his other workshop equipment. It's very powerful. It's gravity powered. Now it's another very subtle design. It's a little difficult to understand it at first, but if you're old like me, you will have come across chairs which have got 4 separate legs, like in this diagram here, or this picture here. If you tilt a chair like that up from one top corner, so that all of the weight of the chair is sitting on one leg, and 3 legs are in midair, you can balance it there so that no real effort is needed to keep it balanced upright. But if you were to move the bit of the chair that you're holding just an inch or so to one side, the chair will swing round to line up underneath your finger. The chair is actually falling, but it's falling sideways. You think of something falling as something that moves closer to the ground. Well, this thing is falling, but it's not moving closer to the ground. And it can fall continuously, and it does fall continuously. Here's a picture of William Skinner with the bottom half of his device. These big vertical cylinders are the weights that he's using to go round and round. You can use weights, you see, rather than a chair, naturally. So if you have a weighted arm and you rotate the top of this arm slowly, the big heavy weight swings round to line up underneath it. But before it gets to underneath it, you've moved it further round. So it has to keep on falling round to try and catch up. But you adjust the speed of your motor so that it never ever catches up. It just goes round and round and round. And if it's any consolation to you, my mother used to scold me for nearly wearing out the carpet from swinging a chair around like that. But you can put a large weight, say the sort of things that you get as a dumbbell weight, onto an arm, and with a very simple arrangement here, you can spin the motor, and that drives through a universal joint, a shaft with, say, bicycle wheel gearing, that is a chain and a sprocket, to drive a 12-volt or other generator. And probably the best generator to use in something like that is one intended for a wind power system, because that's easy to do as such. Okay, that, like nearly all systems, you can start it off with a battery. Once it gets going, you switch over to the output of the generator, which gives you output power and drives the machine and charges your extra battery if you wanted to. But that's a very simple system and very effective. Okay. Is it possible to check if I can be heard? Can we ask somebody?
Yes.
Yeah, you're being heard fine. It works really
Okay,
well.
okay, fine. Thank you. Okay, right. We come on to another system here. This is a rather complicated version of it, This is by David Kwok of Australia. And this is a mains power generator, and he offers them for sale in sizes up to 100 kilowatts. Now what it is two floats. These floats move up and down a vertical metal rod. And the system is powered by compressed air, which is fed in through here from a compressed air tank. When these tanks are filled with air, they want to float, so they move upwards. But as they move upwards, they drag with them a wire which is counterbalanced. And you have one float going up and one float going down. When they get to the top, they're filled with water. When they get to the bottom, they're filled with air. And the entire system then spins a generator. That system can be simplified very considerably, which you'll find in the ebook. It doesn't have to be done that way, and it doesn't have to have compressed air like that. You don't necessarily have to have access to the bottom of your water tank. You can use an existing well if you want. And in India, a lot of the wells have dried up, and people would very much like to use them to generate power. This yellow bar at the bottom is the output drive, which spins the generator. And the generator gives you a lot of power. David calls his design the Hydro, H-I-D-R-O, or Hydro perhaps. And it's very effective. Of course, big generators cost a lot of money. But there's no reason why you can't have a 10 kilowatt or a 100 kilowatt generator if you want. You can contact David in Australia if you wish. Okay, that's a big, heavy, expensive thing. Let's go for something that is extremely cheap and very, very simple. It's from a guy in Russia whose name he uses on the web as Alex Core. He's shared quite a number of different designs. This particular one charges 4 batteries. It's driven by one battery. It has one transistor. It has one resistor. It has one little capacitor and 200 turns of wire on a cardboard tube. It has an on-off switch if you want to be fancy. You don't have to have one. You can just connect to the battery. And it has a neon, which is effectively a spark gap. This particular neon spark gap is typical. It's called a neon bulb, and it triggers somewhere between 90 volts and 110 volts. Now, the reason it's in this particular circuit is this particular circuit is sometimes referred to as a joule thief. But this is a very powerful joule thief. And the current fed in through the resistor to this transistor is quite large. And because of that, the wire on this coil is fairly strong. It's using an MJE 13009 transistor. The transistor has got 3 connections, a base, a collector, and emitter. And the heatsink flap is also connected to the collector. Now this is an extremely powerful transistor. It can handle 400 volts. It can handle a continuous current of 12 amps. It can handle 24 amps if you're going to pulse it. And it can dissipate 100 watts. So it's an extremely potent transistor as such. Some countries sell it under the name of T13009, but an extremely powerful and effective device. So what happens is the circuit operates very simply. The transistor has got an open circuit effectively between the collector and the emitter if no current is being fed through the base. So effectively, there's no current fed anywhere in the circuit. However, if you power up the circuit and current flows through the coil, through the resistor into the base, then the transistor switches on. When it switches on, it drives a very strong current through this red coil, and the voltage at the collector is taken off through this diode and feeds the 4 batteries that are being charged. Now, this is a very effective system. You can use 1 battery and charge 4 batteries. And it is extremely cheap. It's very easy to build. And the particular coil that you wind is just wound with 2 strands of wire. It's not very large amount of wire needed at all. And Alex prefers to use a coil of about 1.5 inches or 40 millimeters in diameter. It's very effective, though.
Patrick, sorry, excuse me.
Yes?
Patrick, hello.
Yes?
Excuse me, Peter here. What is the value of the resistor? Because you gave everything but the value of the resistor. There is no, oh, sorry, not the resistor, the diode.
The diode can be any diode you want. Personally, I would recommend a UF5408, which is 1,000 volts, 3 amps, and very fast acting. But I imagine that Alex just used a 1N4007, which only costs 3p. A diode of 3p is not a problem. But I personally would use a 5408, a UF5408, because they're cheap, they're very powerful, they're very robust. The only thing I have against them is they don't plug in test boards, breadboards. But that's a very simple arrangement and very effective as well. Now, Lawrence Chung also started with the Joule Thief. He calls his system FLEET, Fleet. He reckons that the performance of this particular design is COP of 10. In other words, 10 times more power out than in. I personally use this circuit to check that free energy definitely does exist. But I go on to that in a minute. The system is very careful to avoid taking power off the collector of the transistor. If you take power off the collector of the transistor, it takes current from the battery. If you don't want to take current from the battery, which you usually don't, then ideally what you want to do is take the output power from a second winding around your toroid. Now, this toroid is not a fancy ferrite toroid. This is a big plastic ring. The one that I used was about 8 inches in diameter and about 1 inch across. And I wound it with wire that was available from the local hardware shop. And there are 2 windings on this. Both of the windings are bifilar. So initially you wind all the way around the toroid with 2 strands, and then you connected the standard way for a Joule Thief. This is a typical Joule Thief arrangement. But then you wind a second layer round in a bifilar winding. This is the layer that's shown in gray and blue, if you're not colorblind. And about 30% of men are colorblind. Okay, now I found that I preferred and found it more effective to use 4 diodes instead of 1. So I used a diode bridge, as shown on this particular layout on the right. And you notice that the layout on the right doesn't use soldering. It doesn't use anything fancy. And it shows you which way round the diodes can be connected. I was using 1N4007 diodes because they're effective and very, very cheap. Now, that diode bridge worked quite nicely for me. This particular arrangement worked fine for me. And if I was going to do it again, I would use a TIP 132. That's a low-cost NPN transistor. It has a gain of 1,000, and it is extremely powerful, handles 100 volts, 4 amps, and it is robust. But what I did was I put a 12-volt battery, lead-acid battery, as the output load. I used a 12-volt, small 12-volt lead-acid battery as the input, and no other connections anywhere. So we're talking about one battery charging one other battery. So having done that for some hours, I swapped the batteries over and did it again. Then I swapped the batteries over and did it a third time. Then I measured it all carefully. Now with the lead acid battery, you have to leave it at least an hour for the chemical action inside the battery to finish its operation. Normally the output voltage on the battery will drop while that's happening. So you can't get a reliable voltage measurement on the battery until such time as everything is quietened down. Now, I measured both batteries before and after this, and both batteries had more genuine, usable power in them. But where did the power come from? There was no outside source of electricity. And worse than that, a lead-acid battery wastes half of everything you put into it. In other words, it has an efficiency of only 50%. So for this circuit to have gained power, the dual-T circuit as wound here with two bifilar coils has to have a COP, coefficient of performance, of more than 2. Now, Lawrence Tiong says it's got a COP of 10. I don't know. I didn't check. I just confirmed to my own satisfaction that without a question, free energy is available and you can have it if you want it. There are actually more than 20 different ways of doing it. But if you want to go that route, Ron Pugh of Canada has built a very nice rotational battery charger. It has a COP of 13 when used with a 24-volt input and a 24-volt output for charging batteries. Now, he machined a rotor, very nice rotor, out of aluminium. Now, a word of warning. Aluminium and copper are both highly magnetic, though people will not believe you if you say that. If you try sticking a permanent magnet to aluminium, it won't stick. If you try sticking it to copper, it won't stick. But when you make a rotor in aluminium, the rotor being aluminium has an effect on the end of the permanent magnets that's pointing inwards towards the shaft, the output shaft. But anyway, ignoring that for the moment, Ron gives a way of how to match and pair up magnets, but he's used 6 pairs here with the north pole on the outside, and he positions 3 coils which can be adjusted to the outside of the rim of his circular rotor. Now, when you're running something like this, you can't afford on a circuit of this type to have the input and output battery at the same voltage level. So you have to put the charging battery on top of the drive battery. Now, if you're going to do that, there are a couple of things that you need to do. Ron has wound his particular coils with 5 separate strands of copper wire in each. And he uses one coil to give a trigger as to when the transistor should fire. And he's using another coil to give a drive from the transistor to power the remaining 3 coils. And those remaining 3 coils are shown as connected together as an output. But in actual fact, the way that you should do it is you take 3 diodes to lower the output for the output impedance of the output flow of energy, and you feed each of those 3 diodes, the set of 3, back to the battery you're charging with its own separate wire. This is quite important. You want a low impedance on your diodes and a separate wire feeding the battery being charged. So here you see there are 4 separate wires going to the one battery being charged. That's because the trigger signal is being fed along to different transistors, and each transistor drives one of the coils. It's a very effective way of doing it. Now he's got 3 sections on this, and he uses 3 5-strand coils, but he's able to use 4 of the coils for output each time if he wants. Now you can do it sensibly with separate wires, or you can go the way that he did it and just use 1 wire to the charging battery. It's entirely up to you. But the right way to do it is with a separate wire. Now, this is the way that he built it. He built it the way that John Bedini recommends, that is, in mid-air, using direct connections wire to wire. It's not necessarily the way that I would choose to do it, but then I haven't built this. I do different things. Now, the way he did it is he starts off and he twists the 5 strands of wire together to get a continuously twisted string, which he winds onto a reel. Then he uses his winder to wind separate layers of wire, first from right to left, then from left to right, then right to left, layer upon layer upon layer, until the spool is finished and full. The spool has got slots in the base so that he can adjust them inwards and outwards to find the optimum position. And that is a very effective system that he's using, and very straightforward. Nice quality of work. And we have to thank Ron for sharing his details there. Very impressive. We come now to an interesting one. This is a design from a guy in South Africa who wants to stay he wants to stay incognito. He wants to be anonymous. If you want to know what he looks like, his picture is in the ebook. He has managed to extract nearly all of the components he uses from equipment that has been dumped by companies. He finds it difficult to actually get electronic components, but he's got a lot of these old batteries from uninterruptible power supplies. They've been left for ages and ages, and he's managed to retrieve them and resuscitate them. Now, he's built a device which outputs power continuously, indefinitely. And it's quite a small tabletop device. It's not difficult to understand. It's not difficult to build. This is an initial version that he had. And you notice the red arrow down here showing, again, a slot in the mounting of the coil so that it can be slid inwards or outwards. Now, he started off with this circuit. He built a rotor, and in the rotor he put magnets, and the magnets spin round past a coil which has got metal core. As it goes past, it powers the coils. It feeds, like the Joule Thief, it feeds the current to the base of the transistor, which drops the resistance between the collector and emitter to 0, which drives a strong current through coil number 2. and powers up coil number 3 as well. Now that output from coil number 3 is rectified and fed back to the drive battery here, which is one of his resuscitated batteries. But also from the collector is taken off a UF5408 diode, which feeds a stack of 4 batteries which are being charged. But from one of these batteries, he uses an inverter, mains inverter, and a load of ordinary mains equipment. Now this is very effective, and he found that he could take 40 watts continuously off that forever and ever. Now, being very cautious guy, he ran it for 3 weeks solid, which is a remarkable constraint for an inventor. Really remarkable. Because most inventors let it run for a day or so and say, right, well, let me take it apart and see if I can make it better. But he's done a lot of experimentation on it. And one of the circuits that he's now sharing is this. He's got a central rotor with 5 magnets in, and he's got 5 coils around the outside. He's only using 1 battery. Initially, that 1 battery powers the inverter, gives you 220 volts, and powers a 60-watt bulb. He also powers a mains transformer, step-down transformer, known as a power supply unit. And that, with its diode and capacitor, produces 42 volts, which is used by the transistor to drive the entire system. And the 4 extra coils here take power out and feed it back into the input. And this is a system that uses only one 12-volt battery, very simple in construction. It does have electronics, but not very complicated. Most of what you have there can be got commercially. It's generally speaking not a difficult thing to do, and that runs continuously forever and ever, outputting power. All right, the power is not very large. He claims 40 watts. Personally, I think it's 60, but we won't argue about it. Just let me remark that I can get 1,000 lux of lighting from 1.5 watts. So you can imagine what I could do in lighting with 40 watts. You certainly would want sunglasses, tell you that much. Okay, we come on now to the information. This is from Howard Haley of the UK. He's got very advanced knowledge of free energy and a very considerable understanding of things which most people don't know. This is a 1-wire battery charger.
Can you all hear Patrick?
Now this is particularly interesting. This particular circuit has been independently replicated and confirmed. Okay, it needs some electronics, but ignoring that for the moment, this little 555 circuit generates a charging frequency of pulses. That powers an FET transistor, an IRF 9130 type, as shown here. Now, that drives the input side of a large step-up transformer. The step-up has got 3,000 turns on the outside and 40 turns on the primary. And it comes then through 2 diodes to charge a stack of batteries. A stack of batteries are particularly important, and they charge up, and through a choke which amplifies cold energy, it triggers the neons which are across the silicon control rectifier, the 2N6509G, and that feeds a strong pulse of energy into the battery, or a capacitor if you want to use a capacitor. Now, this is a very important thing itself. First of all, There are differences between conditioned batteries and conditioned capacitors as opposed to ordinary batteries and ordinary capacitors. To condition a battery, it needs to be charged with cold electricity and discharged again many times. Cold electricity is either AC electricity at high frequency, that is typically 20 kilohertz, which I see is misprinted here, or DC at high voltage. Cold electricity flows outside the wires, and so Ohm's law does not apply, but instead current equals voltage times resistance times a constant, which needs to be determined by experimentation. It's also possible to get cold electricity from pulse DC of over 80 volts, and with that method, the sharper and the faster the pulses are, the better. When you first pulse an AC or DC capacitor, it behaves normally, but after about 12 hours of continuous pulsing, the capacitor changes and charges much faster than it did before, and when the power source is switched off, it continues charging, and that can happen for up to 3 minutes. Now, you need to be very careful with this battery charging circuit. It can kill you. This description must not, under any circumstances, be considered to be a recommendation that you should actually build a circuit, as this presentation is for information purposes only. Okay. Now, Howard has tested a conditioned capacitor, connected it between two earth rods, 10 feet or 3 meters apart, and he gave up watching the lit neon after half an hour. So this is the way that it was wired up, and the neon was lit. And the neon needs 90 volts at least to be able to light up. And this is just with 2 earth rods and a conditioned capacitor. And the question has been asked, why in this circuit here do you have 5 450 volt capacitors? Because all it'll charge up to is 180 volts, which any one of those capacitors could manage. Well, the answer to that is subtle. First of all, this is the way that a capacitor charging is represented. The voltage increases, and as it gets fuller and fuller, the rate of increase tails off. The red lines show the average rate for any time period. The steeper the red line is, the faster the capacitor is charging. So what Howard does is he keeps the charging of his capacitors in the first 10% of the capacitor charge. So he uses 5 high voltage capacitors to get a very fast rise of voltage across this capacitor. And that very fast rise is extremely helpful. It's fed through a choke. A choke normally blocks DC pulses, and it lets DC itself in, but it amplifies cold electricity. So the cold electricity is getting a boost in this particular circuit, and then it's fired into the battery as such. Now that's something that didn't really sink into me until recently. Now, he says, importantly, a conditioned capacitor loses its conditioning if it's left unused for some time. In the case of Howard, he found it was 3 weeks. This is interesting because I use this particular DC to DC converter shown here, which is a cheap converter available on the internet. And I used it in this circuit, and I got a bit shocked about this. I used a 12-volt battery and tried self-charging it using this particular DC to DC inverter as being the oscillator. I put in a choke. I don't think the choke is necessary, but I did. And I used it with a 12-volt, 12-amp hour mobility scooter battery. worked extremely well, charged the battery very fast indeed. So I disconnected the battery, measured the voltage, and then let the battery sit for an hour so that the chemical process would stop off and I could get a reliable reading of the voltage, which is normally lower. However, I was amazed to see that the voltage had risen further instead of dropping. I didn't follow up on that because I was busy developing self-powered lighting. When I got back to experimenting with the battery self-charging, I never could replicate that style of charging. But it occurs to me, in the light of what Howard said, that the capacitors on the converter board, which had been heavily used in earlier testing in the lighting circuits, had probably become conditioned, and therefore this circuit was operating differently than it was intended to do. But that is something that I found extremely interesting.